Ah, hello there. My name is Ganesh Ravichandran, and in this project, I designed a graphical user interface in order to analyze adaptive optics images of Kepler objects of interest in support of false positive probability analyses. So, in a nutshell, what I did was to design a computer program that can be used to analyze images of stars that are suspected of harboring exoplanets. Exoplanets are planets outside of our own solar system. In 2009, NASA launched a mission called Kepler, whose goal was to find Earth-sized exoplanets in the Milky Way galaxy. The mission has been really successful, and it's found over 2,500 exoplanetary candidates. But the problem is that these candidates need to be validated in order to be confirmed as official exoplanets. This is a problem because there are more than 2,500 candidates, and the method by which these candidates are validated is extraordinarily slow. Therefore, a new method has been developed called the false positive probability analysis, which basically probabilistically estimates the chance that a particular planetary candidate is a false positive rather than a real exoplanet. In support of the false positive probability analyses, a robotic adaptive optics system called RoboAO was designed in order to take pictures of all of these different stars so that they can be used for these false positive probability analyses. This is where I come in. I designed a computer program called a graphical user interface using the Python programming language in order to manually go through all of these 1166 adaptive optics images so that I could pick out the stars in each of the images and record the coordinates of these stars. These coordinates were then compiled into one giant catalog, and I sent these catalogs back to scientists who were part of the RoboAO team. They then used these catalogs in order to calculate the false positive probabilities of hundreds of Kepler planetary candidates, and they also used it in order to help fix a variety of different bugs that were causing problems in the RoboAO pipeline software. So I actually first started this project when I contacted a graduate student at the California Institute of Technology in Pasadena. His name was Tim Morton, and he was working on this method called the false positive probability analysis. I really loved his FPP analysis because it was a new method of theoretically calculating the chance that a particular planetary candidate is a false positive, which is a lot different than the original Blender procedure that the Kepler team used. The Blender procedure was very, very computationally expensive, and it required a lot of different observations in order to validate a planetary candidate. But the FPP analysis was a lot faster than that. It only takes 10 seconds per candidate in order to calculate the FPP. So I contacted him, and he agreed to mentor me over the summer. And so I traveled to Caltech in the summer of 2012 to start my research. I initially didn't have a lot of understanding of what I was exactly going to do, but as the summer went on, I developed an understanding of the Kepler mission and of the RoboAO project and its place in the context of the Kepler mission. So eventually, Tim offered me the chance to work on this graphical user interface. I began working on the GUI in August of 2012, and it was really hard. I had to use this new programming language called Python, which I wasn't very familiar with. But I read through a lot of different tutorials and read through a lot of different documentation, and I eventually got the hang of it. There were a lot of problems at first with bugs and the fact that I didn't know too much of Python. But one thing that I learned from working on this project is that when you put a lot of patience and a lot of effort into something that you really enjoy, it doesn't really seem like work at all. And so I'm very grateful that had the chance to work on this project. As a result of my hard work, I was recognized by a variety of different organizations for my efforts. I was recognized last year as a finalist in the Intel International Science and Engineering Fair, which was held in Phoenix, Arizona. And this year I was recognized as a semifinalist in the Intel Science Talent Search, which is the most competitive science competition in the United States. I'm also going to be the co-author of a research paper that has been submitted to the Astrophysical Journal, which involves a lot of different observations that have been taken by RoboAO. My project has certainly been very influential for the RoboAO team and for the Kepler mission in general, but it also has a lot of implications for human society itself. I believe that the most important question, or at least one of the most important questions for humanity, is, are we alone? Are we alone in the universe? And that question can only be answered if we look out into the cosmos and try to find these exoplanets, which are the only locations, as far as we know, that could potentially harbor life. That's why the Kepler mission was designed. It was designed technically to find Earth-sized exoplanets in the Milky Way galaxy, but I mean the real uh, dream that every astronomer and I believe every human inherently has is to find out what our purpose in the universe is. And I know that's a very philosophical question, but it's what really drew me to exoplanetary astronomy. It's the idea of being alone in the universe is a very isolating idea. And so I think that a lot of human beings want to know if there's extraterrestrial life in the universe. And the Kepler mission is one step towards that. As a result of the efforts that I made with the GUI, we're one step closer to finding the answer to that question. I still remember the moment that I realized that I wanted to study astronomy, that I wanted to be an astronomer. So my mentor Tim had taken me and a few undergraduate students to Palomar Observatory in Southern California in order to take regular observations of some different stars in the Milky Way. And at one point in the night, around like 2 or 3 o'clock in the morning, we went up to the catwalk of the telescope, and for the first time in my life, I saw the Milky Way galaxy. It actually wasn't as impressive as I had expected at first, because it was just a very, very blurry white patch of stars in the sky. But as I thought about it, I realized how incredibly beautiful it was that I could see the Milky Way on that day in July. I mean, this Milky Way galaxy is what inspired Galileo and inspired Newton and inspired all of these astronomers throughout history to study the universe. And as a result, we have the modern technological world that we have today. And so that's the moment that I realized that I really wanted to study astronomy. And as a result of this project, that love of astronomy has been even more strengthened. I believe that in the near future, as a result of the research that I've conducted and the GUI that I've designed, will become a lot closer with the universe because of new discoveries that that are occurring every day in the field of exoplanetary astronomy. Thank you very much.